So that kind of leads us nicely right back into Ambrosus, in a sense. I mean, what was how did you kind of come across Ambrosus, and how did you, kind of make the decision to kind of get involved? And, is it at all related to your experience with the World Food Program? Is this kind of like a happy coincidence, or what?
So Ambrosus, I think, is a very, it's a pretty lofty goal, and it's something that's very simple, but that has massive ramifications if it can actually be executed. And this is to take a huge amount of lost information in the world and actually make it available. And make it not just available, but make it trustworthily available as well. Now, this lost information is, of course, the information that goes into all of the products that we see around us, that we spend our money on. And it's, at the moment, we rely on comparatively Stone Age techniques in order to understand what the product actually is.
Like what?
Like fair trade certifications, like soil association certification, like brand marks, like questionable technical specifications, like an image on the front of a box. All too often, like the ingredients list, all too often they give us only a very limited perspective on precisely what the product that we are purchasing actually is. And Ambrosus, taken in the widest sense, is a project that's meant to free that information up so that we can understand it better and eventually make better decisions as consumers.
I mean, it's a kind of interesting concept to have more information, and it's interesting that you bring up the kind of brand marks and the kind of ingredients list, like all these things which are intended to give us some sense of kind of transparency or some sense of more information about what we put in our bodies and where it comes from, and how ethical or how sustainable these practices that kind of get these products to us are. I'm curious about, like you said, that it frees up information. I'm just curious, like looking a little bit further down, what do you think that the kind of implications of having much more information in a much more trustless way, I guess is really what I say, is? Like, what is that, jumping ahead, what does that eventually lead to from an automated standpoint or from just like a social standpoint? I mean, is it that does it necessarily mean we're making better decisions? I mean, when you've thought about this project, what does it lead to?
Well, it leads to at least the opportunity of making better decisions. So whether we do make better decisions or not is like more of a question for like psychologists or whatever. But at least we have the chance. And I think the second thing it leads to will be like an overall changing of the market and changing of marketing. I would hope at least that branding becomes a little less important, and that actual techniques, real concrete production environment and mechanisms and logistics and all the rest of it actually take a more front seat role in how people judge what it is that they're going to buy. At the moment, it's very difficult for us to do that. We might have the idea of doing that, but the only thing we can really go off is sort of fairly flaky certifications that miss an awful lot of ground in between, and how much of a good brand, how much of a good sort of vibe we get from a particular brand. Now maybe the better of us actually search online for various products before we actually before we buy, and then we can maybe look at some forums and do some research ourselves, but it's very time consuming, very tedious. And it's oftentimes the information that you actually get is sort of second-hand anecdotal stuff rather than real hard evidence that what you're buying is actually what you want.
So Angel, let's go back to you for a second. I'm curious about how you see what Ambrosus leads to. Like Gavin just said that it's a really kind of lofty ambition. It's a very massive project in a way. If everything goes well, like you launch, you build, everything goes perfectly, like what do you think it leads to? Like what is your kind of ultimate kind of goal or mission? Like how will you know if this is successful?
So to me, it's successful when people actually know what they're buying and they can trust that. So to use an example of the baby food, I want the parents who are buying baby food for their kids not to question what went into it, whether it was stored properly or whether their ingredients did not come from the proper sources. So this is the most important thing. But further on, actually, besides the information being trusted, you can actually make supply chains more automated. So you can actually have smart contracts that serve as real-time auditing for the supply chains. And this is something that interests quite a few corporate stakeholders whom we've brought on board, because they say initially we gave them the promise of, yes, immutability of data and you can trust it, but from then on they said, we visited a facility of actually I can't say their name, but it's a fairly big company in Switzerland that produces food. That's pretty easy to guess. And that company has one huge factory where the baby food and so on is produced. And then next to it, there are 10 other houses just as big as that. And when we visited, this guy said, you see that building? That's the factory. I say, okay, see those other buildings? Yeah, these are the warehouses where we store sample products. So the 10 other buildings the size of the factories where they have to store the required minimum of products so that so that inspectors could come and verify the quality of the product throughout the whole of the life shelf of the product. So it's a lot of inefficiencies, a lot of money for the companies, of course, food waste and so on. So a lot of techniques that they're doing to try and protect the consumers, and yet every year for the last 5 years, the number of food incidents and either that's fake labels or that's incorrect information has only been increasing. So despite all this waste of money, despite all these efforts, the number of scandals only increases, whereas the companies have to go to these lengths. So we want to make that the thing of the past, amongst other things, and we want to make the supply chain management as automated as possible and as trustworthy as possible, so that different stakeholders entering deals with each other could actually do that without having to worry about whether the storage has been correct or whether the other party is actually lying or just not disclosing full information about what came into that particular food product, or the similar logic we discovered actually is applicable to the pharmaceutical markets. And when we did our first partnership with a US-based company called KRYPTO-PARK, who are a public benefit corporation, so they're actually building, they're making pharmaceuticals with responsible pricing, and we discovered that actually the same problems apply there. And when the company has a mission to deliver quality medicine at a low price, they want to make sure that the low price doesn't come at the expense of the quality of storage or handling. So these are the solutions that we're trying to solve, and this is my hope that we can make this process a lot more efficient.
But just walk me through like a use case then. Like what is the user experience of Ambrosus? Like how does it work? Is it a consumer solution or is it like a B2B solution? Like who's actually using this and how does it work?
So primarily on the detailed level, we have actually a video on YouTube that actually shows you how this works from A to Z. But essentially, you have, if we take the B2B case, which seems to be currently the main application case before we actually go towards the consumers, is two parties, they agree with each other on a set of quality parameters for a particular batch of products or products. Let's say temperature of storage, what the weight should be, which we found out is very important, because sometimes you got a boat of salmon leaving one port with 5 tons of salmon, and it arrives with 5 tons of salmon, so it's all right, right? But in the middle, that weight actually comes to 0 because the wild salmon is replaced with low quality salmon, etc. And this kind of fraud or inefficiency exists in quite a few supply chains, so we actually have to set the monitoring for weight that it's constant. So you select some parameters, you select what range should it not leave, so for temperature, that the product is not frozen or unfrozen, etc., etc. And then this data is continuously recorded throughout the traveling for the food, or if it actually passes through another person, then the person signs for it, and the previous party can actually get their payment while the next one is taking responsibility. And then when it reaches the final destination, the party receiving it either scans the tag with a QR code or uses an NFC, and then they can see on their device, on their mobile phone or on the computer, the full history of what actually happened to that particular batch of product. And the history is trustworthy, it's reliable, and if necessary, they can actually connect it to automatic solutions to monitor quality, or if something bad happens, for example, if the storage of the product was not proper, but it's still safe to consume and the quality is still high, you can get a 20% discount, for example, automatically. So as soon as the sensor readings record that something was not really good, but it's still acceptable, you get a discount and then you can continue. So a variety of different commercial applications here varies from supply chain to supply chain, but it creates a lot of interesting opportunities. And then in the end, you've got the end party actually having the full history with detailed overview. And when it comes to the consumers, you can do the same, but with a much simpler interface. So one other Swiss company that is a food retailer, they actually said that they export their food to Asian markets actually, and of course, food produced in Switzerland, it has high standards, so there's no question about what's going on there. But once it leaves the country, then it's when it becomes tricky. And what they want to give is actually the opportunity for consumers, whether it's for food or medicine, to be able to, when they're in a shop, they have a stand where they can tap their phone or scan the QR code and also receive information about their product, but in a much more simplified way. Actually, the latest solution that they're proposing is just like a happy face if everything is all right, and a sad face if everything is bad. But importantly, the consumer can set up what a happy face means for them. If one person is more environmentally conscious or more towards sustainability, they can set up the requirement. I'm conscious about sustainability. So for them, a happy face will only be if the product has been sourced sustainably. If somebody else has different preferences, they can set their preference saying that I don't care about the quality, but I don't care if the piece of meat has flown 20,000 kilometers in the air or something. So these attributes, again, that's not the part of the blockchain, that's part of the actually app development, but it's all connected to the data that is recorded in a reliable manner. So these are the solutions that we've already presented kind of the initial versions to the companies, and they are loving it. Actually, we thought that the biggest benefit would be on our side for supply chains and operations, and many companies have actually, that was the marketing and sales departments of the companies who actually pushed our solution. They said, yeah, maybe it saves us money on the supply chain, maybe the technology is great, but it's also great marketing and great sales boost for our consumers. So this is the kind of the value both for the business stakeholders as well as for the consumers.
Gavin, I'm curious about like the kind of blockchain side of it. I think supply chain is always kind of put forth as one of the kind of go-to use cases for how kind of blockchain can benefit kind of business. So how exactly is blockchain being used in this particular solution? Because if I'm not mistaken, like you came up with there's a new concept of like in terms of how the tokenization is kind of working. Can you explain like what that is and how it all works? The bonding tokens, I guess.
I mean, I guess I don't know. Do you want to go into the token stuff? I'm not sure if what I'm thinking is quite the most recent thoughts on the matter. But blockchain in general is pretty useful for supply chain because it solves two of the major problems. The first is ubiquity, and the second is trust. So with supply chain stuff in general, it's very difficult to pick any individual service provider that should be able to manage or should have any way of managing the world's supply chain data. But you do actually need pretty much a single system to manage the world's supply chain data because it's so entangled. Blockchain kind of solves that quite neatly because it's a system that's ubiquitous, usable by all, much like the internet, and yet it's still not controlled by any single political actor. And in terms of trust, it's very handy because it's hard crypto, it's tamper-proof, which makes it very difficult for any individual party to sort of hack it and change the data after the fact. Of course, you still got to make sure that the actual the source of the data, the oracles, are actually sort of trustworthy. And in this case, we're talking about to some degree sensor data, and in other instances, perhaps certification data or auditors that go and check facilities. In terms of the token, is what I'm thinking the right thing?
We haven't yet published the information on the tokens, but actually we can give it to you, the basics for the moment, yes.
Yeah, so I mean, the main thoughts are that what Ambrosus is going to sort of deliver is the ability to assign or sort of stamp data onto specific products or the prerequisite elements of specific products as they filter through the supply chain and get to the sort of consumer. Now the idea is that the token will be used as a means of not necessarily payment, possibly payment, but also possibly simply bonding to those ingredients or that prototype product as it's moving through the supply chain. So as data is sort of stored within the Ambrosus system, either on the blockchain or through sort of off-chain methods like IPFS, tokens will be locked up in order to sort of partially as a spam prevention mechanism and partially as a means of sort of endowing the token with utility value. As products are moved off the supply chain and get into the consumer's hands, then the tokens will become freed up in order to be used for placing more products on.
Yeah, I found that kind of concept to be really, really interesting, because when we think of these tokens, like we think of them as they just kind of persistent, they always kind of stay the same in a way, they have their kind of value, and then they just, regardless of the context, they just carry whatever value they have, and in this sense, they almost become these almost like blood cells in a way, when they're just carrying whatever kind of nutrients or oxygens from place to place, and then they kind of get recycled. And I love this idea of like this kind of recyclable token, which as we kind of get deeper into tokenization and all the different models and all the different kind of ways it can be used, it's really interesting to see kind of like new concepts like evolve. So I'm pretty interested to see how far this goes and how it gets applied even further down the line. So pretty interesting.
Yeah, this was one of the main interests that actually was registered by quite a few of the strategic stakeholders we brought on board, because the production of Amber tokens will be a one-off event, and then later on, the more companies adopt the protocol or the more supply chains use it, the more tokens are actually just linked up to the product, so the less of them are on the market. So that makes the crypto economics work pretty straightforward in the favor of the rising value of the whole of the tokens. So the initial adopters can actually benefit from adopting Ambrosus technology, even when it's at experimental stages, by knowing that actually the more people adopt it, it creates a network effect, and then the tokens will be used by more and more companies, and then they will have the appreciation.
So I guess that's a good segue into adoption, right? Because my challenge, like as an investor, like my challenge is always that, all right, the technology is very interesting. In many cases, perhaps it's kind of like overblown, and but what really is challenging about the blockchain space is actually having the solutions adopted and driving adoption through large-scale institutions and enterprise. So, I mean, you're not the only supply chain solution out there. Obviously, there are many. Walmart has its thing, and I know like VeChain is also doing supply chain. There's a lot of great solutions out there. I guess what was interesting about yours that when I kind of came across the project was that you have so many like kind of partnerships. Like, how did you do that? Like, how did you get them to kind of come aboard, and why you guys, and how do you kind of keep that going? Do you envision this to be the kind of food supply chain solution, the universal one? And if so, how do you get other people to adopt that?
Initially, well, quite simply, I would say, with corporates, you basically find, you cannot do that directly with people in the corporation, but you can have funds who are financing corporations, and these funds, if they adopt your token and they have direct economic interest in the corporations, then there is a direct incentive for them to adopt Ambrosus solution in their companies, because their value of their own stake increases. So it's a pretty simple method that has worked quite effectively. So basically we created the economic interest for the people financing operations of some of the supply chain companies. And as I mentioned, some of our partners have significant investments in this field. So I was a speaker at Monaco Growth Forums, and there were quite a few Italy and Monaco-based funds who approached us who have a very strong interest in the food industry. Especially, I mean, the Italians are hating on Brussels now for having changed the law on mozzarella. You talk to Italians about mozzarella in Brussels, they go, what? How dare they? Because what they did is they said that now you can produce mozzarella from the powder. And the Italians, they said that's a crime, that's blasphemy. So I told them that we can actually make sure that your mozzarella, even if Brussels tells you to adopt that, you can just use our protocol to prove that your mozzarella is real. So, and they loved it. So it's little things like that. Also, I feel that they've played a big role in all this. And the point is that quite a few people who are invested in the food industry in those regions, we did a use case on the olive oil, which is published on our website in detail. Now it's been published in Chinese as well. And basically, what we're enabling is these funds, they're saying that we're going to participate in your technology, and then we're going to adopt it to protect the quality of our products. but they're very incentivized to choose it, to choose the technology, not only because the technology protects the quality of the product, but because the fund themselves are also there, they hold the tokens. So therefore it creates a double incentive, both the technology incentive as well as a purely financial incentive. And I think this model has been the reason why we've got such a great adoption. And then with governmental stakeholders, quite a few of our team members, they are actually involved in the Swiss government. I mean, myself, I was at the UN. My partner, he's a member of the Swiss Federal Office of Agriculture, and he created the largest food R&D center in Switzerland on food tech, also at EPFL at the Federal Institute. So we've brought in quite a few stakeholders from the governments. So that slightly goes against the whole notion of the blockchain, that it's kind of anti-governmental. We do have a lot of public sector stakeholders, but they realize that actually they cannot fight the blockchain, so they should adopt it one way or another. So we're trying to find a way where we can actually have both the interests of the consumers protected and so on, and at the same time actually have the people on board who can make that happen. Because a lot of projects, they say, yeah, we're going to break everything, we're going to disrupt everything, etc., which we are doing as well. But I like to take a more of a rationalist approach to all this and say, come to the existing big actors and say, guys, this is changing. You've got the great structures on board. Let's try and actually make it better, and we can create common value for everybody. So that's been our strategy.
One last question, and we'll open it up. So Gavin, like, how far is the technology? What is the state of the kind of the Ambrosus technology? How far does it have to go, and what's the kind of technical roadmap like looking forward?
So we're kind of at the stage of doing there's an initial proof of concept that demonstrates pretty clearly what a sort of an early product would look like that is actually works with the blockchain, works with the Coven testnet on Ethereum, and has a nice user interface, and you can sort of see roughly what it's meant to be doing. We're also architecting the overall sort of solution, and that will eventually sort of be the blueprints to what is developed over the next 12 months or so. In terms of the more sort of hardware side of things, because that plays a fairly substantial role in this sort of roadmap. As far as I understand, Maya's team is fairly up to speed. With all
So the detailed roadmap on the hardware has been published also on our technical blog. We have a blog that is just only technical, actually, no kind of updates on anything else besides from technology. And one of the posts there is about the roadmap specifically with hardware part on it. So actually the whole rollout is 3 years, but it's done in modules. So the first working modules for the hardware they're already out now as a proof of concept. So we've got the for existing sensors, the APIs. So we actually are not just creating our own hardware, we also want to bring all the existing ones on board. So we're creating APIs to integrate the existing solutions in the supply chains. But on top of that, we're also building trusted sensors that actually put a signature on all of their readings to make sure that the sensor is not broken and that it's not hacked or compromised, because that is essentially the quintessential part of the future if we want to make this work. Because as Gavin mentioned, the trustworthiness of oracles is important, and a lot of the legacy hardware is not necessarily reliable from that perspective. So we do have to develop solutions that will allow us to actually say that yes, we can guarantee not only that the data recorded is correct, that it's recorded correctly, but that the data itself is true. So from that perspective, the development is taken by the team based at EPFL. We have currently 3 team leads on that. So Stefan Meyer is leading obviously the technology development, but we also have Professors Amstad. So Professor Amstad has now joined us. She used to be a technical advisor. She's now head of science. She heads the lab on soft materials quality assurance at EPFL, and she was formerly a lab leader at Harvard as a postdoc researcher. So she's got great credentials in this field, and she's developing the concept of food tracers with us. The food tracers are basically the sensors that can be part of the packaging or can even be stored inside of it, so they can actually be next to the food And that's been one of the major challenges, because usually the sensors are external. So basically you can replace the content. So even if the sensors record things correctly, you can swap the products. Here we're going to make the packaging itself as the tracer. So it's smart packaging. If anything is broken, it changes the color, and there is a small memory slot to record the data. So this is something which she's heading. The technology is coming also from EPFL and financed by the Swiss government, amongst other things. So it's a project of strategic importance. We use food as a kind of testing ground because that's an easier field to enter than medicine. So with medicine, our initial pilots are actually the implementations planned for next year in 2019. But importantly, the pilots will be the US with Track Therapeutics. As they mentioned, it's going to be presented to the FDA, so Federal Drugs Authority of the United States. And Ambrosus is the technology implementation for that. So basically they develop the medicine and we develop the technology. And if the FDA approve it, we can use it for pharmaceutical products in the US. So we're starting with something that is easier to enter, which is food, but later on we can actually apply it to pharma. And I've also registered interest from Glencore, for example, who said, can you do the same with oil, or can you ensure that the gold has not come from conflict zones, or that it's been recycled sustainably, that people who are recycling the e-waste were wearing masks during the recycling, and that is all somehow registered somewhere and certificates are issued. And these are the use cases that people coming up with more and more use cases. So we're making our protocol open source, we're putting out the code online because we cannot come up with all the solutions that are possible. We want to build a backbone on which people can build solutions tailored for the needs of their own supply chains.
Cool. So why don't we open up the floor to your questions?
Hi, I'm Hugh, CTO of ANX. Super interesting project, gents. I might start with more of a design question. Supply chains are enormous, a lot of data, a lot of volumes. So I guess the amount of data you've got to store is enormous, so you're not going to store every single piece of state. On the blockchain, you're probably going to have some tree or large data blobs that are getting hashed, a Merkle tree or something, so you can reduce the amount of data you actually have to store on the blockchains. But if you're doing that, the value of this data needs to be enormously accessible. So you need some sort of a data structure that you can store large amounts of data off-chain that's going to be stored safely on-chain in a very effective manner. But then the data structure for that off-chain data, you need to be able to access that enormously efficiently. So tell me about your data storage strategy for this project.
So the question is, tell me about your data storage strategy.
So basically that system is IPFS. So that's what we'll be using.
So that's that good data store, and you can store data there. But then whoever's going to access this efficiently, they're going to need some parallel-friendly type of algorithm to actually access the data on top of IPFS. Think MapReduce or anything else. So I guess is that a yet to be designed?
Yeah, I mean, if we're talking that they want to like access gigabytes of data for whatever reason, then yeah, they're going to have some fairly decent hardware and be well connected to the IPFS network and work out their own data logistics to ensure that their gigabytes of data that they want to process is available to them. But the point of Ambrosus is just to make sure the data is in some place available and correct, verifiable. Right. If you want to do massive amounts of processing on it, then you have to figure out your own solution for that.
But aren't they going to have to? I mean, does the system even work if you can't do massive amounts of processing on it?
Well, yeah, no. The point is that the data is there, not necessarily that you've and that you can verify it on chain. So on chain stores Merkle roots or whatever, and you can go to the IPFS network and download the data. And if you see that the data that's somehow stored on IPFS doesn't quite match the thing on Ethereum or whatever, then you can flag it as fraudulent. But I mean, if you let's say you wanted to do a service that actually amalgamated the data and created some summarization or whatever and posted that onto the blockchain as like a secondary oracle, that would be possible. But I don't think that's like a massively difficult problem to solve. We're not talking about gigabytes of data in order to amalgamate and get one data point from it. We're probably talking, sensor readings coming every 10 seconds for a day, right? So it's maybe a few megabytes of data.
No, actually, I completely agree with you on that point, Gavin. That was kind of my point. Like, there's too much data for a blockchain. Okay, so you're going to have to shrink it with hashing or Merkle roots or something. But the very act of doing that creates quite an opaque, hard to work with lump of data somewhere, and that lump of data needs to be stored in a method that's going to be friendly to access, to being accessed with the methods needed by the users. It's kind of a catch-22, that's all. It strikes me as a critical success factor for your project. But that doesn't have to be solved up front either, honestly.
Yeah, I mean, I think it's also important to recognise that it's not going to be the case that all users want to access every single point of data. That's really not what it's meant to be doing. The users will ultimately want to have some completely aggregated piece of information about all of that data, but that only needs to be done once, right? And you can have fraud proofs in order to flag whether that aggregation is incorrect, bonded aggregation, but it can be done very efficiently.
Right. So sorry, Jan.
Okay, that's fine. And then we'll give everyone else then.
So I guess let's imagine that you've got something baby food, and you've tracked every single event relevant to the assembly and distribution of that baby food, and you obviously can't stamp every single piece of state that's happened because it's too much. There's too many jars of baby food. So instead, you've got some off-chain store. You're maintaining a hash. You put less frequent hashes onto the blockchain. But then when you, as a consumer, get a jar of baby food, you want to see some hash, and you want to be able to validate certain steps along the way. Was this really shipped from New Zealand, which is many families may wish for baby food. So, beg your pardon, I know this is. So, how does that validation happen if you've only got a very, very tiny piece of data stamped on the blockchain? You really need to go back into all the raw data and actually follow that through, like a node in a blockchain process in a blockchain database.
Yeah, so I think it's reasonable to look upon this as the difference between like running a full node and a light node. So light nodes don't process everything in order to get to the end result. They just look at what everyone else's sort of end result is. They process maybe a little portion of it to check, some small portion, but they work through the overarching economic incentives that basically if anyone were being fraudulent, other people would have notified everyone else that those were fraudulent, and then they would have suffered some economic loss. And it's likely to be the same in this case. So basically, there'll be aggregation services that do precisely this, that take all of that huge amount of data, and it may just be like in streaming, maybe in real time, so it's like actually every 1,000 measurements gets aggregated, a bunch of rules applied, and then pushed through a smart contract, and then as a secondary oracle that's bonded in some manner, or is run by the baby food company because actually they want people to have this data, and if it's incorrect, if they've made a mistake, or if they fraudulently made some bad amalgamation, then it will be flagged accordingly because other people